I'm a assistant professor in biology in the School of Biological and Physical Sciences. My PhD is in microbiology. I received that at the University of Oklahoma. Just a little background about my experience here at Northwestern. I was a student here from 2000 to 2004. I received a Bachelor's of Science in Biology. And then after that, I went to Nicholls State University and got my master's in marine and environmental biology before going to the University of Oklahoma to get my PhD in microbiology. So while I was there, I was able to study microbes in really interesting habitats such as oil pipelines and landfills, wastewater treatment, and different things, looking at how those microbes took essentially what we would perceive as garbage and make energy out of it, so cellular energy. And in the process of doing that, they will make other energy substrates that we can utilize for our infrastructure, such as methane and hydrogen. Yeah, steam has, obviously it's evolved a little bit from just STEM. For me, that's really it's a natural fit to put the STEAM, the art, into it, as it's often been associated with the College of Arts and Sciences. So yeah, I mean, for me personally, I always find a lot of enjoyment on developing hypotheses and developing experimental procedures and being able to test those things out in an experimental way. Very much as an artist would develop their approach and develop their medium and then execute that experiment or that artistic expression in the same thing. So for me, the two things are very easy to relate together, and I'm excited about this new initiative that we have going on at Northwestern to try to collaborate all of these different departments and schools and try to create something like the STEAM car. Right. Mainly, my interest in STEAM has always been through science. I've always been very fascinated at how something very small like a microorganism could put a hole, for instance, in a pipeline, and then oil spill, all over the tundra. And then that same microorganism, where it caused this disaster in this man-made environment, could be the same way it could be used to clean that oil back up from the environment and recycle those nutrients. So that was kind of my big interest going into microbiology. But as we said before, the correlation to being a scientist and being an artist, it's the same approach. It's the developing a hypothesis and looking at experimental design and executing that in whatever media, whatever form that expression would be. On this team, I'm looking at creating alternative energy for these Mazda engines. So part of this project is we have a new degree here in the School of Biological and Physical Science, and that degree is the Bachelor's of Science in Applied Microbiology. Part of the curriculum is for students to develop their own project. And part of that project is, in my opinion, to be able to take waste, things like maybe brewery waste, maybe wastewater from the wastewater treatment plant, maybe just something that you find, and develop that experiment and grow microbes that could produce things like methane and hydrogen that could then be scaled way up into producing enough hydrogen or methane to be used within an actual engine for a car. Now you need a lot, right? It's a scaling issue, and that's where we're going to have to bring in IET, and we're going to have to bring in engineers and other folks to really collaborate with to figure out how much it would take in order to actually power an entire vehicle.